So this is two problems in one. We're going to start with the velocity function, and we're asked for the displacement. So we're going to take the antiderivative straight up between 0 and 3. And that's the simpler part of the problem. Between 0 and 3, I'm going to use the general power rule in reverse, which gives me this, and I'm going to evaluate it at 3, and subtract 0, which gives me -3/2. So that means that the displacement is negative. It means it's behind where I started. The distance, on the other hand, is a little bit more complicated. The distance traveled is the absolute value of the velocity function between 0 and 3. So the first step is I have to take my absolute value function and split it into a piecewise function, and it switches at 5/3. So at 5/3 it's positive, and I can peel off the absolute value. At less than 5/3 it's negative, so that's why I'm multiplying by a negative, and those signs switch. So when I do my integral, I've got to do it in two pieces. I've got to do from 0 to 5/3, that's below 5/3, so I'm using this function right here. I'm using this function right here. And I'm going from 0 to 5/3 plus the second piece of the function from 5/3 to 3 and integrating those. So once you've established this part, I think the hard lifting is done, and really we've got to be very careful with all our positives and negatives. So doing the integration using the general power rule for the first binomial and then for the second binomial, then I plug in 5/3 and subtract 0 because of the lower integration, plus the next set I plugged in a 3 and I'm subtracting, so this 3, and then I'm subtracting when I plug in 5/3. And when I do my math very carefully, I get 41/6 meters.